All right, so this is just some basic math stuff in general for any kind of course that you're in. You have different kinds of numbers that are classified in different ways. Rational, integer, whole number, natural number. And again, that wording can be used on things, and if you don't even know what the heck they're talking about, it could be a problem even when the question is really easy. So if you notice, these letters they're written kind of like they're double, like with fancy font. We don't necessarily have to get fancy with it. We'll just make them capital. But they do have that kind of doubled look to them. So we're looking at real numbers. The number system itself, where everything lives, are complex numbers. And then we have real and we have imaginary, but we're just looking at the real numbers. So we've got rational numbers and irrational numbers. Those are the two big ideas under here. A rational number can be written as a fraction. Okay, so 0.5 is a decimal, but it's a rational number because it's 1/2, right? Irrational number, I cannot write it as a ratio. Like the root word here is ratio. Ratio and ratio. It either can be a ratio or it can't be a ratio. So if I can't write it as a fraction, like a square root of 2 or pi or something like that, okay? That's your rational and irrational. These three categories have a lot in common. They're not that much different than each other, and that's why they can get a little confusing. Your integers, positive and negative integers, that's your adding and subtracting stuff. Whole numbers, the whole numbers and natural numbers, there's no negatives. Whole numbers include 0, natural does not. And it says also known as counting numbers. I don't know, to me 0 is also a counting number, so whatever, you know. All right, so then we're going to put these in a little Venn diagram here. All right, so we have the real number system. That's the whole thing we're talking about, because we don't even have the imaginary ones in here. Okay. Then, so all of the numbers we're going to talk about are real numbers, and we broke it into two categories, rational and irrational. The irrational is by itself right here. That's your I. Rational numbers, what letter means rational numbers? Look at the top there. Q. So this is the Q, because all these are going to be rational. Then, which one do you think goes next? Which one of the three at the top, integers, whole numbers, natural numbers, would include the other two? So the integers, the other two live inside the integers. Then what do you think comes next? Whole numbers, which is W. W for whole, Z for integer, because I is already taken for irrational. Why it's a Z, I couldn't tell you. I'm sure there's a good reason. And then we have the natural numbers. Okay. So, it says place the following numbers in the correct parts of the diagram. So 1.24. Is that an irrational number? Could I rewrite that as a fraction? Yes, I could. So it's not irrational, so I know it goes over here, right? Is it a natural number, a whole number, or integer? Remember, all these are very much alike. They're all your counting numbers. They're all whole numbers in general, so it's just a plain old rational number. So this is your 1.24 would live here. Okay. So we got that one. -6. Now, is -6 a rational number? Yes. Can I be more specific than that? Yes. What is it? An integer, which is which letter? Z for some reason. Okay. Then we have pi. 3.14159. What do you think that one is? Can I rewrite that as a fraction, an accurate fraction? No, because I know you were probably taught along the way somewhere 22/7, but that's junk. I cannot rewrite it as a fraction, which means it is irrational. It's an irrational number. Square root of 5. Is that a perfect square? No. So it's not going to be a whole number or anything. It's going to be a what? Irrational number. The square root of 5. There you go. All right. Where do you think you would put 2? Okay. It's an integer. It's a whole number. Is it a natural number? Yes. So although it fits in all these categories, the most specific one is a natural number. So that's a 2. What about the square root of 9? Is it a perfect square? Like, can you tell me what the square root of 9 is? What is it? 3. Can you tell me what the square root of 5 is? No, I can't tell you either. I know it's between, 2 and 3 somewhere, but that's all I know. So that's why that one's irrational. Since this actually comes out to 3, it's not irrational even though we're taking a square root. Would it be plus or minus 3? Remember what we talked about yesterday? Did we introduce the square root? No, it's already there. Since I didn't introduce it to solve it, it's just plain old 3. Okay, so plain old 3, so square root of 9 would also be a natural number. All right, square root of 16 over 9. Well, first of all, what is the square root of 16 over 9? Do we need to freak out because it's a fraction under square root? No. If that's your first instinct, no, that's not what we do. This is the same thing as the square root of 16 over the square root of 9. So that gives me 4 over 3. See, it's not that bad. Okay? It looks icky. It's not that bad. So where does that go? What do you think? Rational. Very good, because I can make a ratio out of it. So that's square root of 16 over 9. .45 repeating. Now, rational, good. Because remember, 0.3 repeating isn't that 1/3? If your decimal repeats, it can be written as a ratio. If it doesn't repeat, like pi and the square roots, that's when it becomes irrational. So it is a rational number. So this is 4, 5 repeating. 175, what do you think? Natural number, good. And what do you think about 3/8? Rational. There. Negative square root of 49. Because the square root of 49 is what? 7, so that's negative 7, so yeah. And even though it wasn't a choice, the whole number, what's an example that I could put in the whole number that would be the best? Really the only difference between these two are 0, so 0 kind of lives there. I don't know, it wasn't a choice, but we'll add it there anyway. Okay, easy enough? So, am I going to test you over this? No, probably not. But I just want you to see how the number families live, because we may end up having to talk about number families a little bit more. All right, so on the back, these properties, you're actually taught these at some point in literally elementary school. And then you use them, but I don't think the words are used with you. And I have to stop and think sometimes even what they are, just so that I can keep it straight in my head. But so we have the identity property. Identity property means whatever you do to it, the number stays the same. So for addition, it's going to be 0. Subtraction, it's going to be 0. Multiplication and division, it's going to be 1 because it's going to be the same. So this could really just be here. We'll do A times 1 equals A. Inverse property, what do you undo? So when you started learning algebra and you're like, all right, so if it's addition, I'm going to subtract both sides. You were using the inverse property. It just probably wasn't said to you like that a lot. So 3 plus negative 3 equals 0. So that means in general, that would be like A plus a negative A equals 0. They're inverses of each other. And then 6 times 1/6 so that you can get that 1. And then so we would have A times 1 over A equals 1. The reciprocals gives you that inverse. It undoes it. All right, so commutative and associative, those are the ones that I have to think about, which one is which. Well, the commutative just means we can flip it around. So if we have A times B, A plus B, that's the same thing as B plus A. That helps us sometimes when we're solving things and we can cancel them out even if they flipped around. Multiplication, same thing. 5 times 2 is the same thing as 2 times 5. It does not matter what order you multiply in. So we can say that order does not matter. Hopefully this is like the easiest math lesson you've had in a long time. Okay, so associative, the way I keep that straight is you're associating them with each other. So I have A plus B plus C. Here I have A plus B associated together, then I have B plus C associated together. So it's like you're just kind of grouping them, they're little associations. So we do what? 1 plus 2 plus 3 is equal to 1 plus 2 plus 3. Multiplication works that way as well. A times B times C is equal to A times B times C. So just kind of as a little side note, let's think about if I was going to have to multiply 17 times 5 times 2. Some people multiply in order no matter what. Do you automatically know what 17 times 5 is? Probably not. But instead of, if I don't do those, if I did this instead, what's 5 times 2? 10 times 17 is 170. See how much easier that was so that you can associate? So I think we're all pretty confident that we can multiply in any order, but you also want to think about actually doing it when you're going through stuff. Okay, so that this says grouping does not matter. Does not matter. All right, distributive property. I think we're all, well, here's the thing, guys. You've known these properties, like I said, for a long time. These words have actually been used for you. I know you know what to do. Boy, howdy, do we mess that up sometimes. So if you need to, if you know that that's you, that's fine. There's no shame in it. You can do things like this. What really makes my heart hurt is when I see students do that and still not actually distribute, right? Does that ever happen to you? Because I see it all the time and it makes me kind of sad. So if I have A times B plus C, that is A times B plus A times C. Then we have this closure property that sounds really complicated, but we'll talk about it anyway. Because sometimes we also you have to learn how to read math and like how to decipher the words. Any two real numbers under these operations will produce a real number. However, not all subsets that we talked about are closed under all operations. That wording sounds weird, right? What it's saying, so you're closed if the operation always produces the element of the same set. So if I have two irrational numbers and I add them together, I'm always going to get another irrational number. But if I have two whole numbers and I subtract them, I might not get a whole number, I might get an integer or something like that. That's what that means. Again, I'm not going to quiz you on it, just math words and that property. Honestly, I don't know those I've ever actually seen it in a lesson before. But all this sound familiar? Right? Was this the easiest math lesson you've had in years? Hopefully. But if you're ever on a game show and you win money because you know what the Q stands for and you know your number families, you better give me a call and give me a piece of that.